All right, we are looking at target 7.8. Okay, and in target 7.8, we're going to determine if a binomial is a factor of a polynomial by using synthetic division and applying our factor theorem. Okay, what am I trying to do? The picture's background. So, before we learn about a factor theorem, there's one other thing we have to learn about, which is the remainder theorem. And the remainder theorem says f of a is equal to the remainder of f of x divided by x minus a. Alright? Let's make this a little bit. It's frozen, I think. Hold on. This is actually dot's a little bit bigger, so that it is actually a division symbol. Okay, so I can divide in order to find a value. Okay. Given f of x equals 3x to the fourth plus 2x cubed plus 5x squared minus 2. Find f of negative 2 using synthetic division. I want to rewrite this really quick because this is 3x to the fourth plus 2x cubed minus 5x squared plus 0x minus 2. We are missing one of our terms, so we want to be very careful with that. And then I'm going to bring down my coefficients. I have 3, 2, negative 5, 0, negative 2. And I want to find f of negative 2. This is already x equals negative 2. I don't have to switch it. I don't have to solve for anything, right? I'm just putting negative 2 here, okay? So if it's given x plus or minus something, then you have to set it equal to 0 and solve for x. If you're given x equals something, you're already done. Then bring down. 3 times negative 2 is negative 6. Add. Negative 2 times negative 4 is 8. Add. Negative 2 times 3 is negative 6. Add. Negative 6 times negative 2 is 12. And negative 2 plus 12 is 10. So what this tells us is f of negative 2 equals 10. I think this is a lot easier than trying to plug negative 2 in and figure out what it is, right? Negative 2 to the fourth and then times 3 and third, right? There's a lot more math, especially as things get bigger. Again, sometimes with these squares or cubes, right, we can do those, but if I was thinking of much larger numbers, right, it's a lot easier just to do your synthetic division. Okay, same idea. Given 5x squared plus 2x minus 1. I'm not missing any terms here. So I have my coefficients 5, 2, and negative 1. And I'm going to find f of 3, and that's x equals 3. So again, I'm going to bring down. 3 times 5 is 15. 3 times 17 is 30, plus 21, 51. Just 50. So f of 3 equals 50. Okay. We're going to do one more of these, and then I'm probably just going to skip example 4. It's not that different. And this is in order, so I'm good there. And there's a 1 here. 5 and 3, right? Taking my coefficients. So I have my 4 out here. Bring it down to 4 times 2 is 8. Bring it down 9. 9 times 4 is 36. Bring it down, that's 31. 4 times 31 is 120 times 1 is 4, so 124. 4 times 3 is 120. 4 times 1 is 4. Yep. And then bring that down 127. All right, we're not going to worry about example 4, right? Very much similar, same idea. So let's move on to what factors are. So your factors are numbers, variables, or expressions. Alright, so it could be just a number, it could be just, or an expression, so like x plus 5, right? Some of these things we've been seeing already, right? So that's what I mean by expression, okay? That multiplies to the given, polynomial. Okay. So for example, just a quick example, 2 times 3 equals 6. So both of those are factors of 6. All right. Okay. So then our factor theorem, what does our factor theorem say? Our factor theorem says that if the remainder of p of x divided by q of x, so one divided by the other, is equal to 0, q of x is a factor of p of x. Okay, so if the remainder is 0, then yes, it's a factor, which makes sense, right? I should be able to, since I can multiply these, if I divide them, they divide evenly, right? That's really just what the remainder of 0 means, it divides evenly. Looking at these two quick examples, right? I have 8, 3, 4, 8 divided by 7, right? Well, 7 goes into 8 once. 7 goes into 13 once, and 1 times 7 is 7. That's 6. 7 goes into 64 9 times, because 9 times 7 is 63. And then 7 goes into 18 twice, right? And 4 7s. This is our remainder. So not a factor, right? I did all my long division and it was not a factor. Here I have 8,064 divided by 7. Goes in once. 7 goes into 10 once. 7 goes into 36 5 times. 7 goes into 14 2 times. 7 is a factor. Right? So we're going to do the same idea. Can I actually evenly divide it, but with polynomials? Okay? So looking at our next page, use the factor theorem to determine if x plus 5 or x minus 2 is a factor of f of x equals x to the fourth plus x cubed minus 21x squared minus x plus 20. We have x to the fourth, x cubed, negative 21, negative 1, and 20. So I want to check if x plus 5 equals 0, just be minus, x equals negative 5, right? I was given an x plus or minus, so I have to solve for it, versus if I'm given an x equals, right? So I bring down that 1. Negative 5 times 1 is negative 5. 1 minus 5 is negative 4. Negative 5 times negative 4 is 20. Negative 1. Negative 5 times negative 1 is positive 5, which gives me 4. Negative 5 times 4 is negative 20. Okay, so x plus 5 is a factor because the remainder is 0. Now let's check if x minus 2 is a factor. I have to do the same thing. So I have 1, 1, negative 21, negative 1. So I'm going to add 2. So we have x equals positive 2. Bring it down. 2 times 1 is 2. 1 times plus 2 is 3. 2 times 3 is 6. Forgot my 20. Sorry, guys. Pretend that was always over there. That's negative 15, which is negative 30, which is negative 31. 2 times negative 31 is negative 62, which is negative 42. That is not 0, right? So x minus 2 is not a factor because the remainder is not 0. Okay. Same idea with example 8. Use the factor theorem to determine if x equals 2 or x equals negative 4 is a 0 of 3x cubed minus 8x squared plus 10x plus 28. So I can use my synthetic division, and I have 3, -8, 10, and 28. I want to know if x equals 2 is a factor of that. This is already x equals. I don't have to do anything extra. 3 times 2 is 6, which is -2. -4. I get 12, which is 40. So x equals 2 is not a 0. Because remainder is not 0. Alright, so same idea, but right, I just showed it's not a 0, it's not an x-intercept, right? Again, same thing. It has to be 0 if it's going to be on there, right? Doing the same thing with that x equals -4, setting it up, I have 3, -8, 10, and 28. And this is already set up. So now we're doing the same thing where we bring down our 3. Color. And then -4 times 3 is -12. Got a negative. Oh, I forgot the negative there too. We'll fix that. -20, 80, 70, -280. Ooh. That is not a 0. That is -262, 52. Okay, I realize a mistake I made. Some of you might have caught it and are now hearing me do it when you're like, oh yeah, I was paying, I saw that already. -14. 2 times -14 is -28. It is 0. X is a 0 because the remainder is 0. Sorry about that. Next, I'm going to fix this for next year by pushing this onto the next line. Okay? Sorry about that mistake, but again, it's still just exactly what we did yesterday. We're still just doing synthetic division. At the end, you just gotta look, do I have a 0 or don't I have a 0? And that's it. Last set of examples. Okay, so you're given a polynomial and the factor. But one of our coefficients is a variable now. And we're trying to figure out what that variable is. So, I'm going to treat this A like a coefficient. I can spell coefficient. So, we set it up. These do go in order, so that's good. So we have 1, -2, A, and 20. Here we have our x minus 5. Now I'm just going to do my synthetic division like normal. I'm going to bring down my 1. 5 times 1 is 5. -2 plus 5 is 3. Sorry. 3 times 5 is 15. Now here's where it's weird. Now I have A plus 15. Those aren't like terms. So I'm just going to write it exactly how it is. Multiply, well, 5 times A is 5A. 5 times 15 is 60. Gonna add. I now have 5a plus 80. Okay. Now, x minus 5 is a factor. So, the remainder is 0. Well, this is my remainder. So you're telling me this is 0. Yes, that's exactly what I was saying. Right, now we have a very simple, easy equation that we're solving. I'm going to subtract 80. I have 5a equals negative 80. I'm going to divide by 5. And I believe we get negative 16. Okay, so we can solve for this weird coefficient if we're given a factor because we know this has to be equal to 0. Same idea for example 10, right? Given x cubed plus ax minus 12, and x plus 1 is a factor, what is the value of a? Now again, I have to be careful. I have cubed to x. I'm missing a term. Okay. So now I can pull out my coefficients. I have 1, 0, a, negative 12. We have x plus 1. So that goes over here. Negative 1 times 1. 0 minus 1 is negative 1. Negative 1 times negative 1. Right? And negative 1 times negative 1 gives me 1. And then I get a plus 1. Negative 1 times a is negative a. Negative 1 times 1 is negative 1. Then I have negative a minus 13. So again, I know this is equal to 0, right? So negative a minus 13 equals 0. Add 13. Get rid of that negative. So a equals negative 13. Okay? That's it. I'll see you guys tomorrow. I don't have to solve.